Approximately 85% of all matter in the universe is thought to be made up of this substance. Dark matter has never been directly seen and remains one of contemporary physics' major mysteries. Despite not knowing exactly what dark matter is, scientists do know that it is necessary for galaxies to form. Dark matter, on the other hand, cannot be observed because it does not emit light. However, scientists are aware that something exists within galaxies that is not apparent to the naked eye or with scientific apparatus. So, what is this enigmatic space substance known as dark matter? And why are scientists working so hard to figure it out? Join us today as we discuss the riddle of dark matter, which has now been solved. Let's get going. Dark matter is a mysterious substance that is virtually undetectable save by its gravitational pull. Despite this, astronomers estimate that it comprises about a quarter of the cosmos and dwarfs the amount of regular matter in space, such as galaxies, stars, and planets. It may surprise you to learn that we have no idea what makes up our entire cosmos. Don't be alarmed. An Oxford scientist has offered a novel idea that could solve one of the universe's greatest riddles. For a long time, scientists thought the universe was expanding but would eventually slow down. When NASA's Hubble telescope was launched and began peering into space, it discovered something strange. The universe had no intention of slowing down. It was growing at a breakneck speed. It was perplexing. It was impossible for an astrophysicist to explain. They debated a few different possibilities before settling on this one. Dark matter and dark energy make up 95% of the cosmos, two substances we can't see, but that scientists believe exist because of their impact on visible things. Dark matter and dark energy have previously been thought to be different substances, but Jamie Farnes, an astronomer at Oxford University, believes they may coexist as a dark fluid of negative masses. The fluid would therefore have a negative gravitational force. It would push objects away instead of dragging them toward it. It's an unusual idea, but it's not new. Farnes' idea, which was published in the scholarly journal Astronomy and Astrophysics, explains a number of the universe's strange traits. Galaxies, for example, spin so quickly that they should split themselves apart. However, it appears that a dark matter known as halo prevents such devastation. Furthermore, the new idea proposes that the negative mass dark fluid is responsible for the formation of these halos. Negative matter, on the other hand, is a dilemma because it implies that dark energy will become less dense with time. And observations show that this isn't the case, that dark energy remains stable. As a result, Farnes employs the theory of matter production, which holds that more and more of this substance perpetually pops into existence, replenishing the negative matter that vanishes. For the model, his paper incorporates a fantastic illustration concept. Space-time is empty, but it behaves like popcorn, with new negative masses popping into existence all the time. Delicious. So the black fluid theory is just that, a computer simulation and math-based theory. Farnes is cautious because it could be incorrect, and scientists are right to be skeptical. On the surface, it resembles some of the characteristics of our universe. But now the question is whether it can explain the rest of our universe observations. Professor of Astrophysics at the University of Sydney, Geraint Lewis, stated, "Before we can say this is equivalent to our current understanding, we must first complete a series of tests. Then we must determine what predictions this model makes that the present cosmological model fails to make. As a result, one of the most important issues to address is the negative mass problem. We don't know the details of the mechanisms that could cause such an occurrence, according to Lewis. We can write down equations for numerous things, but we won't know whether or not those equations are physically realized until we test the cosmos," he said. That implies that there is work to be done. And research into the existence of negative masses comparable to those hypothesized by Farnes is already happening at locations like CERN, the European Organization for Nuclear Research. Another project, the Square Kilometre Array, which when completed will be the world's largest radio telescope, could assist Farnes in getting his hypothesis off the ground. We have to keep pushing the boundaries of fundamental physics because every time we open up a new area, it appears arcane and strange at first, but it gradually becomes part of our everyday life, according to Louis. Aside from these arguments, scientists have made another compelling case. Earth is part of the visible universe. Protons, neutrons, and electrons packaged into atoms make up the Sun, other stars, and galaxies. Ordinary or boronic matter takes up less than 5% of the universe's mass, according to one of the most startling findings of the 20th century. The rest of the cosmos, on the other hand, appears to be made up of a mysterious, unseen substance known as dark matter and a force known as dark energy that repels gravity. As previously stated, scientists have yet to directly observe dark matter. Because dark matter does not interact with baryonic matter and is completely invisible to light and other types of electromagnetic radiation, it is impossible to detect with present tools. However, because of the gravitational impact it appears to have on galaxies and galaxy clusters, astronomers are convinced it exists. According to traditional physics, stars at the galactic center, where a galaxy's unseen mass is concentrated, should travel far slower than those near the periphery of a spinning spiral galaxy. Observations, however, demonstrate that stars orbit at roughly the same speed, no matter where they are in the galactic disk. If the boundary stars are feeling the gravitational effects of an undiscovered mass, dark matter, and a halo encircling the galaxy, this perplexing result makes sense. Certain optical illusions observed by astronomers in the deep universe could be explained by dark matter. Images of galaxies with bizarre rings and arcs of light, for example, could be explained if light from even more distant galaxies is being distorted and magnified in the foreground by vast, invisible clouds of dark matter, a phenomena known as gravitational lensing. As a result, scientists have a few theories about what dark matter is. Dark matter, according to one popular theory, is made up of strange particles that don't interact with conventional matter or light, but nonetheless exert gravitational attraction. Others believe that the impacts of dark matter could be explained by fundamentally altering current gravity theories. According to such theories, there are various types of gravity, and the large-scale gravity that governs galaxies is different from what humans are used to. Dark energy is even more enigmatic, and scientists were taken aback when it was discovered in the 1990s. As we previously stated, physicists thought that the gravitational attraction would slow the expansion of the universe over time. However, two independent teams attempted to quantify the rate of deceleration, and they discovered that the prior study's findings were correct, as expansion was really speeding up. One researcher compared the discovery to tossing a set of keys into the air and expecting them to fall back down, only to watch them soar straight up toward the ceiling. Scientists now believe that the universe's accelerated expansion is caused by a repellent force generated by quantum fluctuations in otherwise empty space. Furthermore, the force appears to be strengthening as the cosmos expands.